Hey guys, my name is Jae Wilson. I'm a freelance consultant through my company Onyx Reporting, and today we're going to take a look at the Kmains clustering algorithm. Very exciting, but I know it doesn't sound exciting yet, so let me clue you into what this is really about. Last year, I was working with a client who was trying to figure out where they needed to open a car dealership, and they sold really high-end sports cars. And they're like, yeah, we have a good idea where we think we want to open our dealership, but do you have any like data science-y backed ways of backing this up? So we said, okay, well, why don't we look at zip codes where people are registering $500,000 cars? And let's make sure that in each of those zip codes, there is a dealership within X number of miles. And K-means clustering was the mathematical way we could approach this process. You know, it's super easy to like look at a map and be like, there, that's where I want to do the thing. But is there a mathematic way that doesn't require eyeballing to get that done? Another example, imagine you're a hospital, right? And you have two ambulances. And you're trying to figure out where in the city should I position my two ambulances so I can minimize the amount of time it takes or the distance an ambulance has to travel to respond to an event. How would I approach that problem in a algorithmic way that doesn't say, okay, let's eyeball it and just set them at opposite ends of the city? In terms of how does K-means actually work? Well, let's look at this example here. So you start by picking out your data or mapping out your data points. So here they are on a grid. Here are my events that took place in blue. And because I have two ambulances, I've got my ambulance 1 at location A, my ambulance 2 at location B. Cool. First thing you're going to do is you're going to say, hey, for each of these points, which ambulance are they closest to? So the light blue are all closest to ambulance 1. The dark blue are all closest to ambulance 2. That's all pretty straightforward stuff. But we're not done. There's no reason to leave the ambulances out at the outskirts of the city. What I could do is say for segment 1, what if I find the centroid or the midpoint that minimizes the distance between all of these lines of latitude and longitude? So basically take the average, right, of the lat long for group A, and then I'll take the average of lat long for group B. That's my new location, my new best location for my ambulances. But here's an interesting question. Having moved my ambulances from the outskirts of town more towards the center of town, does that change the distribution of my data points? Does it reassign? Notice this guy down here is light blue, down here now it's dark blue. Does it reassign my events to a different ambulance? Notice up here, this guy was dark blue, down here it's light blue because it's actually closer to the new location of ambulance 1. So we need to loop through this process. We need to loop through this process of assigning my points based on the minimum distance, finding my new centroid, the new best location, reassigning the points based on distance, find the new centroid, We'll loop through that process several times until the distribution of my points doesn't change, where they will continually respond to the ambulance at that same location because this is the optimum place for my ambulances. And what's my goal? My goal is to minimize the distance the ambulance has to travel to reach all of my customers. Now, again, that loop that we described is something that's really difficult to do in Domo. MySQL doesn't support loops. Sorry, Magic 2.0 doesn't support loops. And if you've seen me in the dojo before, I said you have to start thinking about what's called a set-based operation. How can I shape my data to minimize the requirement that I need a loop? And we can do that. We can implement a loop in SQL. I try to avoid it. In this instance, I have to loop because I have to calculate my new centroid and rerun some math based off of that centroid. And I have to do that an indeterminate number of times. Okay, so if I can get my mouse back, what does that look like? Well, I have some sample data that I pulled. I think 99 rows of data where I've picked up some points in the middle of the ocean or in the middle of in Mexico and South America in the ocean. Right, we've got some points here. And our question is, what's the best way to segment them? Let's say, we saw sharks at these locations, and we're trying to figure out where's the best place to position my boats to increase the chance that they see a shark. And then, of course, we have sharks on land because Sharknado. Okay, this is sample data. How can I implement something like this? Oh, and in terms of clusters, right? Obviously, dark green, my centroid's probably there. Purple, my centroid is there. Blue, my centroid is there. Orange, I've got a couple points down here. And then I've got this weird outlier point that is creating a centroid way down there. All right, how did we create this? This is very exciting. For starters, I Googled it. I knew in my head that my problem was a K-means clustering problem. That was challenge number one. Challenge number two was like, how do I calculate the distance between 2 points using latitude and longitude using MySQL? Again, I'm not going to lie, I didn't write this code. I Googled it. And do read through the Stack Overflow article because there are some gotchas, like the introduction of this least function that will save you compared to some of the other code that I was looking at. Speaking of other code, again, I'm a smart cookie, but I'm gonna stand on the backs of giants or shoulders of giants. Somebody wrote the loop, the stored procedure that would loop through this thing. Now they did use the row count function, which tells me that they're using MySQL 5.7 plus or 8 plus, and Domo's on 5.6. So we can't do a row count function. So I did have to like code around that. So those are all the caveats. I used other articles. You should use other articles because, all right. What I recommend is you break down your problem into small bits and chunks. My first problem was, can I calculate the distance between 2 points using MySQL? That was problem number one. And then problem number two is, how do I do the loop? And again, I found articles to help me. All right, so let's go through this. In my data, I've got, like I said, 99 points. They all have an ID, a point of latitude, and a point of longitude. Easy. Where do we take it from there? Well, because I was following this article, I kept some of their conventions. I created a data called kmdate. It's got the location ID, latitude, longitude, and I needed a column for the cluster ID. The cluster ID is going to be the ambulance that's assigned to this location, right? What is the ambulance I should send in response? And then, right, if all 5 of these points were ambulance 1, to find the new centroid, I would just take the average of the latitude and longitude, and I'd say that's where we should position the ambulance. And we're going to see that a little bit later. To test my test clusters data set is going to be the location of my ambulance. So in my example, I said, okay, well, I've got 3 ambulances. I'm going to randomly position them here. For the purposes of my code, randomly positioned means I just took the first 3 data points and I said, that's where I'm going to stick them. Now, all of my other points, what ambulance would you get aligned to if we went through this process? And so in order to do that, I have my data, I have the location of my ambulances, and I'm going to do a cross apply or a Cartesian product. For each location, I want to be able to test it against the location of my 3 ambulances. And then I want to calculate the distance between those points, again, using the code that I lifted off of Stack Overflow. And so my result says, for location number 1, for incident number 1, the distance between ambulance 1, 2, and 3 was 0, 546, and 1.24 kilometers. So the best ambulance would be the closest. Let's get past the initialization data. All right, for location number 9, positioned at this point of latitude and longitude, Ambulance 1 was 0.6 kilometers, ambulance 2 was 546 kilometers, and ambulance number 3 was 1.79 kilometers. The best ambulance to send would be cluster ID number 1, ambulance number 1. That's the math. Okay? Sweet. So now we need to go through this process. Like, we know we can calculate the distance using latitude and longitude and math. And actually, just so you can see it, I did set myself up with some test data. I said if I test with lines of latitude, longitude 3680, and I test with an ambulance located at 3779, would I get the right answer? And I tested it using a real website. It said, hey, if you're here and there, your distance is 143 kilometers apart. And I ran that code in MySQL and I got the right result. The trick to all of this complicated stuff, guys, is to break it down into little bite-sized chunks. Understand your problem, understand its application in the real world, find an article or something where somebody has solved this problem in a different format, and then just, steal people's code and make tutorials about it. Why not? Okay. Where are we? So to actually put this into implementation, I'm going to create a column called KM clusters. It's very similar to test clusters, which again will be the location of my ambulances, the points where my ambulance are currently located. Every time I loop through the process, though, the location of the ambulances will change, right? The cluster location will change. And that's why we're creating a separate table for this. I'm including a counter column because what I want to do is I'm going to loop through this process. I just picked an arbitrary number 1,000 times. Ideally, with Kmains, you should loop through the process until your centroid stops moving, until your centroid is in the best location possible, and moving it around is not going to improve your results. I don't have a good way of doing that, or I was too lazy to write anything more sophisticated. So I'm going to just choose to stop at 1,000 loops. All right, stored procedure is where the magic happens. So if there's anything in my ambulances table, we're going to truncate the cluster. Okay, fine. And we're going to initialize with our x or v underscore k with our random number of, not random, we're going to initialize with a set number of ambulances. For this code, we have 5 ambulances. All right, so the repeat will do the loop. And we're going to loop until the counter is reaches 1,000. Then we end. All right. So what are we doing? The first thing we're going to do is we're going to assign our clusters. We're going to assign our data points to an ambulance. So for each data point, find the distance that is the closest and set the cluster ID equal to the ID of that ambulance. Just basic math. By the way, this was the original code that was given in this article that I was following, but I wanted to use the real distance, which again I validated using the Hurricane Center's distance formula. Okay. So I did use different code for calculating the distance in kilometers, and I'm choosing the closest, right? That limit equals 1. I'm choosing the closest ambulance ID, and that's what I'm populating in my data set. Okay. Once we assign everything to every data point to an ambulance, then we update our ambulances and say, hey, is there a better location for them? And to do that, we find the average of the latitude and longitude for each cluster ID. For all of my data, find the average, the new best location. Then we're going to increment our counter, and we're going to repeat this 1,000 times. And that stored procedure is what's doing my procedure. So I'm going to call Kmains. I'm going to call my procedure with 5 ambulances. And then my resulting set says, okay, Here are all of my data points. They are aligned with this ID. Sorry, these are all of the data points that are assigned to this ambulance. And if I look at the distance in kilometers, we expect these numbers to be very low. Okay, how far away were you? A fourth, 0.4 kilometers, 0.5 kilometers. If I start seeing 20, 30, 500 kilometers, we're probably in the wrong cluster. But these numbers are all relatively low. My clustering looks pretty solid after 1,000 loops. Okay. Again, what does that visualization look like? It looks like this. My ambulance is somewhere around here, and these points are the closest to that. All right. So guys, my name is Jae Wilson. I'm a freelance consultant through my company, Onyx Reporting. Obviously, I do a lot of pipeline engineering. I know Domo very well, but the value I bring to customers and organizations is helping them take a business problem. Where should I position my ambulances? Where should I open a new dealership? And aligning that with an algorithm borrowed from data science that initially starts very simple, but that we can deconstruct into like little bits and pieces that we can bite off and chew and implement, and then we can layer on complexity, right? For my ambulances use case, you might say, well, Jay, these points are really they only happened like very infrequently. They're spaced very far apart. Whereas over here, I get a lot more activity more frequently. So maybe I need to have more ambulances on the west side of town because there's more incidences than on the east side of town. Right, that layer of complexity, that time component is something you can layer in, but this was just a very simple example of some easy to lift and shift code executed in MySQL with a nice little loop in there to kind of get us started with this problem. Anyway, my name is Jay Wilson. I hope you liked the video. If you did, please like the video, subscribe to the channel. If you want to, you can donate to the channel. There's a little button on the channel page. And we'll catch you guys later. Bye.